Welcome back to the second episode of developing the ArrayList, an ArrayList clone in C. And last time we have implemented the get method and an add method to add elements to the ArrayList and to retrieve elements from the ArrayList. Yeah, we've learned quite a bit about structures in C and how to pass by reference and access the members of the structure and all these kinds of things. I was not really familiar with that, so I hope this time it works a bit better. And I would say in this episode, I would like to attempt to implement a remove method. And that's what we should start with now. So let's first check out how to implement it, or how to at least design it from a method signature point of view. A remove method should, I don't think it needs to return anything. It should remove an element if it's present, else it should remove, well, it should return nothing. Or maybe it would be a good idea to have a look at the ArrayList documentation of Java. Yeah, let's have a look at that. ArrayList Java doc. There's a remove method and it removes the element at the specified position in the list and returns E. I guess E is the element that is stored in the list. Yes, so okay. We have to return the character array, the string. Then remove is the name of the method. And we are going to remove at the index of the list. Yeah. Int I index and then pass the struct lists by reference because we want to remove from the list. And then we also need some documentation. Removes element at index I. And I think this should be it. It should compile at least. No, it does not. Why did I abbreviate structure or struct by strc? strc. This needs to be struct. And now it will compile. No, it will. It still gives me a. Is it an error? Yes, it's an error. Conflicting types for remove. Have character pointer. What? Why is this a conflicting? What does it mean? Line 21, conflicting type for remove. Have character pointer int struct list. In file included from ArrayList C. Conflicting types for remove. Standard IO, previous declaration of remove, aha. So standard IO already declares remove. I would like to see how to view C header files in Linux. I know there's a directory for that in Linux, but I would like to have a look at that. So where are they? Let's try to find it. Find in the root directory and then in probably in library 64, I guess. And let's look for name standard io.h. Nope. Then let's just look in the root directory for now. User include standard io.h. Okay, that one looks promising. I would like to open that one in here. User include standard io.h. There are multiple standard io.h's, but we're just going to pick any of those. I mean, the definitions should be roughly the same, and I just want to see how remove is defined. So remove removes a file name. There are But if there are two methods called remove and they have different signatures, I mean a different return type and different argument types, then they should not conflict, should they? What is the error? Conflict in types for remove. Have character in the... It says I... what? What if I just remove remove element? If I call it like that, does it still conflict? No, so it's really due to the method name. But I would like to call my method that, because that's the same name as the ArrayList in Java. C conflicting function. Conflicting types for function in C. Why? You're trying to do something before you... Okay, that is not called a declaration, that is called the function prototype. I need to remember that to be precise in my speech. Which, well, we have a function prototype. I think we have to implement the method here, and then it won't conflict anymore. I think it's the complaint is that we receive a method from the header, and we define a new function prototype here, and when we call remove, no, we don't call it yet, but I think it does not like that there's a prototype that conflicts with the header declaration or the header definition, and then there's no implementation for that. So I would say I will copy that line, paste it here, and implement something now, which is the plan of this video anyways. So how do we remove an element from the list? Actually, what does it do in Java? Does it remove the element from the list and then leave a null behind? Or does it remove the element from the list and then rearrange the entire list? That would be a large difference. And that would be good to know. And to find that out, I would say we should consult the Java docs again and check for the remove method. Removes the element at the specified position in this list. think it does not rearrange. Oh, it does. Removes the element at the specified position in this list, shifts any subsequent elements to the left. So that is the challenge. Subtracts one from their indices. Yes, but should we just subtract one from the indices? I'm not sure about that. Let's see. First, we're going to remove the element somehow. We're going to have to read the value first. And the value that we're going to read is a character pointer. And it is the removed element. And it is equal to the list. I think we can just call the get function here. Get I and then pass on the list. This should return already the removed element. Like that. Okay. But before we return the removed element, we can and we should and we have to actually remove it somehow or overwrite it. And that is going to be not as easy. We have to, what do we have to do? We have to somehow shift all subsequent elements to their respective previous index. Sounds like something we need a while loop for, or a for loop. Let's do a for loop, and we start at index. We have to start at index I and go to, and go to the current end right here, defined right here. So for index I, no, we need a new counter variable. That is int c or count for count equal I. Well, count is smaller than current end I plus plus. And what do? There's probably a really nice and neat way to do that in C, but I'm just going to do it simply the way I think of the problem. Now we have to write into the list. We don't actually have to remove anything. We just have to overwrite what we already have at index I with what's coming next, with the next element after that. So L, and we access the element. Should we call the get method all the time? No, I don't think that's a good idea. We have to do, what do we have to do? Can we just get the address of, well, L, which is a pointer, and just decrement it once? No, we can't, because L does not start at I. We have to get L at index I. and write into it L at I plus 1. Yeah, that should do it. And we do that until we reach the current end. So the last count is 1 smaller than current end. This means we yeah, that should do it actually. That should do it. Let's just try that out. This that should do it. Throws thousands of errors. Error conflicting types for remove. Why? It's still the same thing. The method prototype is not welcome. Okay. Remove element. Let's call it remove element and make our lives easy for now. Remove element like this. And here I would like to call the compiler again. It does not work, but the error list is much smaller. The error list, not the array list. It's just this. In function, remove element, line 55, for count equals I, count smaller than current end. Of course, this has to be count plus plus. And then I have to say count. This is ugly, but okay. In function remove element, line 55. Why? Remove element at I. Count is smaller than current end. Count plus plus. L at position count. Current end. What is wrong with current end? Okay. I got it. Current end is not defined globally. It's not a global variable or a constant. It's defined as part of the struct, of course. So we have to access the current end of the struct like this. This looks weird because of the what are they called? No. Special characters in English. Brackets? Are they brackets? No, they're not. These crocodile mouths. Special characters list as key. There's a name for every character in here, I guess. This one. Less than sign. But is there not a better word for that? The less than and greater sign inequality. Inequality sign names. Programming. angle brackets. That's what I needed. The angle brackets. Okay, angle brackets. The two angle brackets here are well facing opposite directions, and it looks a bit confusing. I can add space here, but does that really solve it? No, but actually this, just to emphasize, where this is the operation that takes precedence. The arrow operator takes precedence over this comparison operation here. And that compiled. If we do a out, we get the usual print out. And I would say we can print this again, and then also do another test by saying printf before removal and then after removal, like this. And here I would say we can print the array, print array like this, print array list, and then we remove something from it, remove element at index, let's say 1, and provide the list, and then print the array list again. So what is the expected output? We add the values hello world exclamation mark, and then we remove the value at position 1, which would be world. So we would get hello exclamation mark as a new output. I bet it won't work because we have to decrement the current end. Let's see. Something's not working. Do we have to provide anything else somewhere? Remove element from list, from the address of the lists. Okay. Okay, before removal, hello world, segmentation fault. That means remove element does not work properly. Is it possible that I destroy my machine if I code something wrong here? I mean, right now the OS is protecting me from memory corruption and memory issues by saying, hey, you're producing segmentation faults, or you're accessing wrong memory, or writing something wrong. But is it possible to code something in C that it accidentally, through a bug, destroys your entire system? It would be interesting to know. Put it in the comments, please. Okay, we remove an element. Well, we get a removed element first. Get IL. I would love to see where the segmentation fault is thrown, but let's try to work it out manually first. It must be by trying to write into... It must happen here when we try to write into the list. List at count equals list at count plus 1. The list is a pointer. By accessing the index, we dereference it and we access the value. So that should be fine. I need to find out how to use GDB with source code. That would be nice. Because so far I have not found out how to use it together with that source. GDB can print parts of your program's source. Since the debugging information recorded in the program tells GDB what source files were used to build it. When your program stops, GDB spontaneously prints the lines where it stops. CC compile debugging information. The G tells the compiler, at least using GCC, to store debugging information. Does that exist with the CC compiler as well? CC help. And then let's search for G. Options starting with G, etc. are automatically passed onto the various subprocesses invoked by CC. Okay, it does not seem to be the same as in GCC, but let's search for the keyword debug. No. CC debugging symbols. Let me just try it. ArrayList.c. Okay, no error. GDB a out info symbol. Well, okay. Break, and we want to break at remove. It auto completed, so that's good. Breakpoint 1 at file ArrayList line 59. Okay, that's good. That's good. And I think we can run a out now. Okay, so that the debugging information worked. Remove element IS1. We're in line 59 now. We're right here. And let's just do step. Okay, now we just stepped into the get method. Do another step, do another step. Now we're in line 62 in the remove element method. And I would like to know info local. Is there a difference between local and locals? No. Info local. Removed element is world. Okay. Why does it start with so many 5s? I mean, it's all different characters, not all the same character. But I don't think we have to worry about that. Maybe it's 5, 6. No. That is maybe a D, L. I don't know. It must be the address of world. It must be the address. Count equals 0. Removed element is world. That is correct because we say hello world exclamation mark and we remove the element at index 1. Why does it not say that we remove the index 1? Because that is not a local variable, that is an argument. Yeah, and here it says 1 and it says the address of L of the structure that we're using. Okay, that's interesting already. It's nice to get to know this debugger for the first time for me. And What else do we need? We can just step info local. Count is still 1, and I think if we do another step, then we get the segmentation fault. But before we get it, let's just print args, and let's do the step now. Yeah, program received signal 6seg_v segmentation fault in remove element. Why? Count is, what is count? Count is I. I is 1. So count is 1. That is correct. If we access L at index 1, that should be the same as saying L plus 1. No, the dereferenced L plus 1. That should be the same as L at 1. That is my understanding. So I think something about my understanding is wrong. Info. What does stack say? Okay, that's the stack trace, similar to Java. Info display. Count equals count plus 1. Well, I'll just Google the segmentation fault when accessing. Is it a struct? It's a structure. I'm accessing a structure, and I'm accessing that structure. Yeah. Okay. We've passed on to this method. If you already knew what's going on, then sorry for all that. And we've passed onto this method the structure list. And we passed on a pointer to a list. The pointer to a list, well, it is, as you see here, well, it's just an address. It's just an address of a single list. That's what we passed, because that's the structure. But what we want to do is we want to remove the element, or we want to shift the elements contained in the array member of that list. So that's what we have to do. We have to do L array count. Let's see if that works. I totally forgot that this is not the list itself, the list where that is holding the data, but the array inside the list is what is actually holding the data. So we can exit this, ccg ArrayList, and I would say let's give it an output name as well. Remove the A out, and then do ArrayList. And after removal, it worked. That's great. So let's check a couple more detail cases. We can add a couple more elements here. How are you? Question mark. Compile that, execute ArrayList. We are getting the values at these indexes, at these indices. That works. Before removal, we're printing the entire list. That works as well. And after removal, we see that hello, how are you is still printed. The world is omitted because it's removed. And we have to now also update the current end index. And we can do it like that, current end minus minus, like this. That should be it. And this way we can avoid this problem of having the null recognized as an element of this list, because this integer is not used, this index is not used anymore. Current end minus minus does not work, of course, because we have to operate on the lists. So let's do this, and that should work. Hello, how are you? Great. Okay, so that's already very nice. I like that. I like that a lot. What is missing now? I think what is missing is that this array here does not resize. We have a storage capacity of 1000, but it might, we might have to update the size of it. I mean, if the array grows too large, then 1000 is not a good limit of that. I have rarely used array lists that were longer than that. Usually they are quite a bit smaller, but we should still consider that. And maybe one other thing is we should test if removing more elements than we have available, if that works. So let's remove 3 elements, all at index 1, and we should get an updated printout. After removal, hello, are you? Okay, that seems to work, but what if we remove a couple of more elements? That will definitely break. After removal, it prints nothing. Okay, let's remove more. After removal, it does nothing. Why does it do nothing? What it tries is it tries to remove element at index 1. The get method should already return null, because if I is bigger than the current end and the current end is likely 0 if no elements are present, then it returns null. So we have a null and removed element. Then for count, we're providing 1. As long as count is smaller than the current end, which is 0, we're incrementing the count. Okay, so this we don't even enter this counter, but we are still decrementing the current end. So I guess if we append something new, add 1, so we're adding a value, let's say hello again. I'm not sure if that even works, because we're appending it to current end, and current end is negative. Yeah, and that's that's a bug. So hello again, we have to remove that. And we have to decrement current end only if how do we do it elegantly? Well, that's just very simple. If L current end bigger than 0, then decrement it like this. And here I would say let's test again to add something. Add hello again to the list, and this should work now. I have to compile first, and this works now. Okay, so we can remove elements from the list. Yep. And what else do we need to do? We need to check that removing elements from behind current end does not work. Let's try to remove element number 100. Let's print the array list. Before removal, after removal. Before removal, it's hello world, how are you? After removal, it's hello world, how are you? And the last element is removed. Why is the last element removed? Rather, when we're providing an invalid index, it should not remove anything. So remove element at index 100 is, well, we are retrieving the element at 100. That's larger than the current end. So we reach the null case, or we should reach the null case. But the current end is still being decremented. That's so tricky. The current end is still being decremented, although no element here has been shifted. So we have to, what do we have to do? We have to check if the remove element, well, if this is even in range. And for that, maybe the same check would make sense here. If it is in range, we can basically code the very same code, can use the same code here. Like this. And then we decrement only if we're providing an index that's within the range. So now that bug should be fixed. Yes. Fine, I'm happy with that. Okay, I would say this is it for today. This was how to implement a remove method in our ArrayList clone in C. And if you enjoyed watching this, then please leave a like and subscribe to this channel. There will be more coding videos, much more coding videos, where we will embark on a common challenge to learn as much about coding as possible. And I hope you enjoyed this as much as myself. Probably you know much more than me, maybe you don't, and just following along hopefully makes or enriches your day somehow. And if you enjoy this, then please leave some positive vibes in the comments. If you enjoyed this, then see you next time. Bye.